Good day, guys. Today we're looking at the inverse of a matrix. Now, we have looked at one of this before, but today we're going to look at two more examples. So let's look at the first one. It says, given that A is 3, 4, 6, 7, so the inverse, which is going to be A to the negative 1, is equal to 1 over the determinant, which is represented by AD minus BC, times the adjoint, which is represented by D, negative B, negative CE. So the inverse of A is going to be 1 over 3 times 7 minus 6 times 4 times, open bracket, 7, negative 4, negative 6, 3. So this will give me A to the negative 1 is equal to 1 over 3 times 7 is 21 minus 24 times 7, negative 3, negative 6. I'm sorry, negative 4. So 7, negative 4, negative 6, 3. So that's going to mean that the inverse of the matrix, this is going to give me negative 1/3. So I'm going to have 7 over negative 3. And negative 1/3 times the negative 4 is going to be 4/3. And negative 1/3 times negative 6 is going to be 6/3. And this will be negative 1. So notice this gives us a nice inverse where you have 4 elements. Let's look at the second one. Given that L equals negative 5, 2, 10, negative 4. Again, the inverse is going to be 1 over the determinant. And the determinant is AD minus BC times the adjoint, and the adjoint is D, negative B, D, negative B, negative CE. So L to the negative 1 is going to be equal to 1 over negative 5 times negative 4 minus 2 times 10 times negative 4, negative 2, negative 10, negative 5. So L to the negative 1 is equal to 1 over 20 minus 20, which is times negative 4, negative 2, negative 10, negative 5. But note, 20 minus 20 is 0. So that's 1 over 0, which we know is not possible. Alright? So we say this has no inverse because it is a singular matrix, which means that this one has an inverse because it is a non-singular matrix. So there we see the difference between a non-singular and a singular matrix. Thanks. Hope you enjoy.